Chapter 1, Section 10, Probing Cell Structure, Electron Microscopy. Now, what do you do when a light microscope just does not have the magnification you want? And you can only take a picture from a light microscope and increase it so much with a computer before it just gets too fuzzy. Well, first, get rid of the light bulb, go to a laser like we talked about with the confocal, and then you just get rid of the microscope and the lenses altogether. You use a laser and you either bounce it through your specimen or you use a laser and you bounce it off the surface. Passing a laser through, transmission electron microscopes. You use a laser and you pass it through whatever, and notice how there's a shadow on my face because of the hand. Well, all the cellular components, in the cell, as that laser passes through, are going to create a shadow. Well, that shadow is what you take pictures of, and that's the shadow of the ribosomes, the proteins, the nucleic acids, the different organelle membranes. That's what you examine. Or you bounce a laser off the surface and you see what's on the surface of. Laser hits the surface, refracts, and then you have a chamber full of different gadgets. Can't think of the word right now. Different things that are going to then capture the laser and then measure, because the computer knows exactly where your specimen is. And as the laser hits and then bounces off, there's going to be a sensor, that's the word I can think of, that's going to say, oh, just got triggered. And the computer is then going to back calculate at the microscopic level what had to have happened. You look here. This is a transmitting electron microscope. Not those little things that you play with in lab. This thing is about 3 to 4 feet tall. This little entry right here, what they call the sample port, this is where you put your sample in. Your slide that's got bacteria, that have been heat fixed onto it. Or some form of a slide that has, tissue slices, so that you have, you've taken like a lung tissue sample and you've gone through and you sliced it just a few microns thick, basically shaved off slices. Put it in there. Here's the laser that goes through, and then you look, and here is the shadow down in here in this view area. You'll have a camera that's hooked up to a computer, and then the computer will go through and calculate, and here's what the picture is, here's the magnification and all of that stuff. Is it that simple as I've just said it? No. There's a lot of steps in there that I'm just completely ignoring. But for all intents and purposes in this class, that's how it works. So what you can see here is 2 bacteria. How do I know bacteria? No internal organelles, DNA nucleoid, no nucleus mentioned. Cell wall, septum. The laser had passed through the bacteria, and what you're looking at here is the shadow. Picture of the shadow caused by the laser light, some of it being blocked, just like here with my hand. My hand's blocking some of the light from that light bulb. And that's what you're looking at. You can go through, and it is very high resolution. Magnifications here measured in the hundreds of thousands, up to the millions on some really good high-end ones. Same bacteria type, I believe. Using a scanning electron microscope, the laser bounced off the surface, and then a sensor measured the refraction, refraction to calculate, and then the computer used all of that data to sit there and generate this picture. I want to know what's happening inside the cell. I want to know what's happening on the surface of the cell.